Day one, we're going to look at solving systems of equations by graphing. So the warm-up is what we did last unit, looking at drawing lines with different types of slopes. So we'll start there. So can you draw a line with a positive slope? And we've talked about how a positive slope goes up from left to right. So here's an example of a line with a positive slope. A negative slope goes down from left to right. So here's an example of a negative slope. Zero slope, it's when it's flat or horizontal. So here's an example of zero slope. And undefined slope is when it's straight up and down, an x equals equation versus a y equals equation. Also, last unit we looked at graphing the following equations. So we have y equals 2x minus 1. The y-intercept is -1. The slope is 2. So what that means is we'll go up 2 to the right 1, up 2 to the right 1. Then we'll connect our line. That's not great. Okay, so here's an example. Here's an example of what the line y equals 2x minus 1 looks like. How about this one right here? This one, they put the y-intercept first, the number by itself, so 5, but it's a negative slope, so we're going to go down and to the right instead of up and to the right. So we're going to go down 3, 2, 3, over 4, 1, 2, 3, 4. You can do that a few times or just twice, and then we'll connect our line. And so here's the equation of the line 5 minus 3/4 x. And again, we talked about we have a y equals line. The y-intercept is 2. The slope is 0. So it would be a flat horizontal line at y equals 2. And then if it's an x equals line, we're going to find where x is 4. All along this line, x is 4. And so our x equals lines are vertical. Okay, we went backwards as well. If I gave you a line, could you write the equation of this? So this line right here, I'll write the y-intercept first, -2. Our slope is +1, so we can write -2 plus x, or you could also write x minus 2. Means the same thing. This one right here, we have y equals, the y-intercept is 3. Our slope is negative, and it's 2 over 3, and we'll put the x next to our slope. We have a horizontal line at y equals -2 and a vertical line at x equals -3. So quick review, because today we're going to look at solving systems of linear equations by graphing. So that's why we're reviewing all the graphing. Definition: a system of equations is a collection of two or more equations with the same set of unknowns. So today we're going to just spend time looking at word problems, defining variables, setting up equations, and then solving a system of equations by graphing. So number one, Brady and Allison both plan to run for a spot on the school board in their city. They must each collect a certain number of signatures to get their name on the ballot. So far, Brady has 15 signatures, but Allison just started and doesn't have any. Yet, Brady is collecting signatures at an average rate of 5 per hour, where Allison can get 10 signatures per hour. Okay, so there are two variables that we're looking at. We're looking at the total number of signatures. So we'll put y as the number of signatures. And the other thing that's changing here is time. And time here is the independent variable. And so that would be the number of hours we're looking at. Okay, we have Brady and we have Allison, so let's write their equation. So I'll start with Brady. How many signatures does Brady start with first? It says he has 15 signatures, and he collects it at an average rate of 5 per hour. So 5 signatures every hour. Whereas we have Allison, she doesn't have any signatures yet, so 0, but she will get 10 signatures per hour. Okay, so there's an example of two equations. So this is the new part. This is called a system of equations, when you have two or more that look at the same information, the same variables, signatures and hours in this case. All right, let's graph these equations right here. So I'm going to start with Brady's. His y-intercept was 15, and he goes up 5 every hour, which means that every 2 hours he goes up 10. Okay, so let me think. This was 15. Okay, so if we're graphing this, we're going up 10 every hour. So 5, 10 over 1, 5, 10 over 1, 5, 10 over 1. Okay, so here is what Brady's line would look like. His linear function. And then we have Allison. She starts at 0, but she gets, ooh, I did Brady's wrong because I did 10 for him. I was looking at Allison, so redo. All right, so Brady does start at 15, but he only gets 5 signatures per hour. So his should look like this. 5 every hour. Okay. So there is Brady's. And Allison starts at 0. She's the one who gets 10 signatures every hour. So I'm going to go up 10 over 1, up 10 over 1, up 10 over 1, up 10 over 1. Connect those. Okay, so here's a graph that has Brady and Allison's equations. Assuming that the rate of collection stays the same, eventually the two will have collected the same number of signatures. How many signatures will they both have, and how long will that take? So when you're solving a system, what are you trying to find? You're trying to find where the two lines cross. And so if we take a look, here is where they cross. This is at the point 1, 2, 3, 30. So let's talk about what this means. 3 is the x value, so this is hours. So we could say after 3 hours, they have the same amount of signatures, and that number would be 30 signatures. All right, so they would have, if they only had 3 hours to collect signatures, they would be tied. If they had less than 3 hours, who would win? And that would be Brady. If they had more than 3 hours, then Allison would win. So that's the type of problems. Okay, so here it is. How many? They will have 30 signatures after 3 hours. Okay, let's try another problem. A video rental company offers a plan that includes a membership fee of $10 and charges $1 for every DVD borrowed. They offer a second plan that costs $40 per month, and they have unlimited DVD rentals. So I'm going to assume the membership fee we'll say is also per month. Okay, so let's define variables. All right, so there's 2 variables here. X, we could say the number of months. Okay, so I guess this membership fee we'll say is a yearly membership fee. Okay, so X is number of months. And we have Y will be the number of, well, this will be the total cost. Okay. Okay, so not number of months. Let's do this again. Okay, so membership $10. Okay, so number of DVDs. So X is the number of DVDs. And Y would be the total cost then. Those are the 2 variables that we're looking at. Okay, let's write our equations then. So first we have plan 1. So plan 1, again, what's the starting cost? And that's that $10 fee. And then they charge $1 for every DVD rental. And we said X is the number of DVDs, so $1 per DVD. So there's plan 1. Plan 2, however, costs $40 per month for unlimited DVD rentals. Okay, so X doesn't matter in this one. All right, let's graph these 2. So I'm going to graph 2 first because I have the blue. So 2 starts at 40, and there's no slope right here. So $40 flat fee. All right, let's take a look at plan 1, which starts $10, and it's $1 per DVD. Okay, so if it's $1 per DVD, when we go over 5, we will go up 5. Over 5, up 5. Same as going over 1, up 1. Okay, so here is what our line would look like. If a customer borrows enough DVDs in a month, the 2 plans cost the same amount. How many DVDs is that, and what is the cost? So again, when you're solving a system, you're looking for where do they intersect. The 2 lines intersect, and here's where they cross, and that would be at the point, it looks like 30, 40. So let's talk about what that means. X is the number of DVDs. So if they rent 30 DVDs a month, it will cost the same, and Y is cost. It will cost $40. So when they rent 30 DVDs, the cost for both plans will be $40. Okay, let's try one more, and actually 2 more, and then you should have enough to start your practice problems. Ahmed, an office manager, needs to find a courier to deliver a package. The first courier he is considering charges a fee of $20 plus $3 per pound. The second courier charges $10 plus $4 per pound. Again, let's define our variables. Okay, so here X, looks like the thing that's changing is the weight, so number of pounds. And then the cost will be what we're trying to calculate. Okay, again, 2 couriers. We'll say our first courier is number 1. And they charge a fee of $20 no matter what, plus $3 a pound. Okay, courier number 2. They charge $10, but more for every pound. So there it is. Okay, let's graph them. I'll start with the 20 plus 3x. I'll start at 20. And we are going to go up 3 over 1. I think this will be easier for me to make a table. Okay, so let's do that for courier number 1. I'm just going to need a few more points. I'm just going to pick at 10 pounds and at 20 pounds. How much will this cost? So when we plug in for 10 pounds, we're going to do 20 plus 3 times 10. And so that would be 50. And let's plug in 20 pounds. Okay, so if we make this a 20, erase that. 3 times 20 is 60. 60 plus 20 is 80. Okay, so now we can graph this pretty easily. So go over 10 up to 50, go over 20 up to 80. Okay, so sometimes it helps to make a table to graph our values. Let's look at plan number 2. Again, I'm going to make a table here, and we're going to plug into this equation. So again, I'll do 10 and 20 pounds. All right, so for 10 pounds, it'll be 4 times 10, which is 40, plus 10, which is 50. And for 20 pounds, we'll do 4 times 20, which is 80, plus 10, which is 90. Excuse me. Excuse me. Okay, so let me double check that 4 times. Yep, okay, that looks good. All right, so 10, 50, 20, 90. And the y-intercept for that one was 10. Ooh, I didn't use my line tool. Okay, so here's what it looks like. And you can see, again, the plan 1 started out more expensive, but pretty quickly it ended up costing the same. And where was that point of intersection? Sorry, it's not there. It looks like it's about right here. But I didn't draw my line great, so let's try it one more time. Okay, there's better. Okay, so here's where it should intersect. We can see it from the table. So right here, we would say when the weight is 10 pounds, the cost is $50. So this is the weight, and this is the cost. Okay, so it says how much will it cost? We know it will cost $50, and the packages weigh 10 pounds. All right, last one. The members of a cooking club are making cakes, which they will sell at a street fair for $8 a piece. It costs $20 for the booth at the fair, and the ingredients for each cake cost $4. Can you write a system of equations to represent the situation? And they're going to say, okay, your 2 equations should be for the sales and for expenditures. Okay, so let's see, it costs $20 for a booth at the fair, and each ingredient costs $4 for each cake costs $4. Okay, so here we have to write our system of equations first. So we'll say X is the number of cakes that we're selling. And Y will be the dollar amount that we're looking at. Okay, so for sales, okay, so we're selling, and we can sell the cakes for $8 a piece. Expenditures, okay, so it costs $20 plus $4 for supplies for every cake. Okay, let's graph. Okay, so the first one for sales, the y-intercept 0. The slope is 8. So instead of trying to go up 8 over 1 again, I'm going to try to make a table. So x, y, and I'm just going to pick cakes to plug in. I'll do at 4 cakes and at 8 cakes. And so I'm just going to plug them in. 4 times 8 is 32. So again, we're just plugging into this equation for x. 8 times 8 is 64. All right, so now it's easier for me to graph these points. 4 will go up to 32, so about right there. And 8 will go up to 64. Oh, I should go lower than that then. Let's just do 6 cakes. All right, so 6 times 8 is 48. Okay, 6, 48, there's 50. So 48 is about right there. Okay. So here's one line. And that is sales. Okay, let's do expenditures again. I will just pick points. I did 4 and 6. I'll do them again. And plug in. What is 20 plus 4 times 4? That would be 36. What is 20 plus 4 times... Okay, so I'm going to write down 20 plus 4 times 6. 20 times 4. Okay, that's right. And that would be 44. All right, so 6, 44 would be like... Okay, so first 4. First we should do the y-intercept, 20. And then 4, 36. And then 6, 44. There's 45, so we'll say 44 is right there. Okay. That line's not great. Okay, so if we're looking for a point of intersection, it appears to be about right here. And so that would be at 5 cakes. They both cost $40. Okay, so it says at some point the club members will sell enough cakes so that their sales cover their expenditures. How much will the sales and expenditures be? So again, if they can sell 5 cakes, they'll break even because they've sold $40 worth of stuff, but they've spent $40 worth of stuff. All right, so that's day 1. We're solving systems by graphing. In this unit, we solve systems many different ways. So here's just one of the many ways we'll look at solving a system.